Is it working? So we'll be starting session soon, so please take your seat and be quiet. Okay, so this session will be about IPython, the notebook, how to use IPython. Should be a very, very interesting talk. It will be presented by Matt Davis, so I give him the relay. So please give him a warm welcome.
Okay, I think we got it. Thanks, guys. So I'm Matt Davis, also known on the web as Jiffy Club. Since Matt Davis is such a common name, I had to differentiate myself. And I'm going to tell you a bit today about how or why the IPython Notebook is a good choice as an educational environment for teaching Python or teaching computation with Python. You can follow along with me in the online version of my talk at this URL. So I do most of my teaching with an organization called Software Carpentry. And we go all over the world teaching software engineering skills to scientists in short 2- or 3-day boot camps. We teach things like the shell, like version control, unit testing, and we teach them Python. Our typical student is not a programmer. We're teaching them Python to get them out of Excel, to get them writing reproducible data analysis scripts so that when people have questions about how they got their results, they can just go back to their script and look at exactly what they did, rerun it if need be. And we focus just on the fundamentals, usually on things like for loops, if statements, getting them to just write functions, developing computational thinkings and the thought process required for developing algorithms. And it is a really tough day. We usually take about a day to do this, and we throw a ton of stuff at them, and it's going to be tough on them, and we want to help and make it as easy as possible. And we can do that by lowering the mental load required of them. In cognitive load theory, there are 3 types of load that students have to deal with when in any learning situation. There's intrinsic load, the yellow, which is the inherent difficulty of a subject matter. Learning quantum mechanics is going to tax your mind. Then there's extraneous load. This is extra load associated with the learning environment, with the teaching materials. For example, learning quantum mechanics in a language you don't speak fluently, you have this extra translation step, right? That's not really related to the material itself. And finally, there's Germane Load. This is processing power spent actually understanding a topic and connecting it to existing knowledge, which is essential for developing, to integrating new knowledge into long-term memory. And students have a finite amount of processing power, and you want them to devote as much as possible to this germane load. And to do that, we have to take away extraneous or intrinsic load. Intrinsic load can be hard to target, but extraneous load we can do something about. And the IPython Notebook can help with that. So you've probably seen the notebook by now, but if you haven't, it's an interactive browser-based interface to a Python process, and I'm in Chrome here, and we've got a bunch of Python here, and I can execute it and see the result. How does this help us? Well, for one thing, it looks the same on Mac, Linux, and Windows, and across all of the supported browsers. So when students look at their screen, look at your screen, look at their neighbor's screen, they see the same thing in every place, and they know exactly what to expect. There's no translation step from what you're showing them to what they're going to have to put into their own system. Everything happens right in the notebook. You put in code, you see the result. There's no window switching, no going from an editor to a terminal. In my experience, this is one of the most important things the notebook gives you. Students get so easily lost when you're switching between windows. Just as they're trying to get caught up, you switch over to the terminal, and they lose what you typed into an editor. And at the end of the boot camps I do in software carpentry, somebody always complains about the time I spent switching windows. They just hate it. It's even possible to start up a read-only notebook server so that students can actually connect to your computer over the local network and see your working notebook and scroll to things that have gone off of your page or off of your screen. Very handy. So here's an example of executing some code here in the notebook, right? My little for loop here. It's very easy to modify this, right? To change the step size or something, and very quick to see the results here. And I can change something else. And unlike the traditional interactive prompt, editing multi-line blocks is no problem. We just put the cursor back in where we want to make a change, do it, and re-execute. And this leads to a really fast process of trying stuff so that students have way less time to kind of forget what they were trying to do or to forget their goal or to get kind of mentally derailed, which is very nice for them. And you can see here that this is actually kind of like a miniature editor here. We've got some syntax highlighting. It does automatic indentation. There's tab completion of variable names and class names and everything. Very handy. And that leads me to IPython's help features. This is probably one of the more popular reasons people pick up IPython is for its integrated help. First, the tab completion, which everybody expects from the shell. But there's more, especially here in the notebook. So if I import some stuff, and then I want to know what it does if I start to type out the call sequence and wait a second, or if I hit tab, this little window pops up with the call signature and the first line of the doc string. If I press tab again, that expands and becomes scrollable, and I can scroll through the entire doc string for this class and find out what arguments it takes, in this case what attributes it has, and get the total rundown. If I want this to pop up someplace a little more static, I can use the question mark syntax here, and this little frame will pop up at the bottom that shows basically the same information, the doc string and the parameters and the argument, or the attributes there. Then I can collapse that back down. If I actually make one of these things and take a look at the variable here, so type out the variable name and a dot, press tab, I get a nice list of all of the methods and attributes on this class. And all of these help features kind of put hints at students' fingertips. So they were like, what was that method I was supposed to call? They just hit tab here and see their options, and they can be like, oh yeah, that one, I remember that. Or if they're trying to write out the call, they hit tab, the little window pops up and says, these are the arguments this thing takes. Help jog their memory, and this can lead to some self-led exploration and learning. We're in the browser here, right? So we should be able to display things like HTML, CSS, nice looking stuff. And we've got hooks to do that. And that capability opens itself to all kinds of options to make extensions for the notebook to facilitate programming lessons by hooking into that and showing really nice looking interactive stuff. And the community has come up with a couple of examples of that, extensions to the notebook you can use in the classroom. This first one I'm going to demo is a project of mine called Ipython Blocks. And what it provides is a class in the notebook that represents itself as a colored grid. And students have access to those individual blocks within the grid, and they can change the color. And we can experiment with things like for loops and if statements here, where we're going over the grid and doing one thing if the cell is in one place, a different thing if the cell is in another place. You can even animate it. And so students can kind of be like, I can tell students, change the color of all of the blocks in the second column, and they'll write a little code and then run it, and they can tell right away whether it worked, right? Either the blocks in the second column changed or they didn't. And maybe nothing changed, maybe a different column changed, and so they can figure that out really quickly. This also supports practicing things like indexing and slicing. And the visual feedback seems to really help students. I have a couple more demos of this. There's a file format associated with these. So here's the beginnings of a text file that contains a spec for a grid. And so the students can get practice loading and processing a text file. And once they've got that function, see what was in there. You can just have fun. You can just get creative. This is a grid of pixels, basically. So if you have a little bit of understanding of RGB color, you can start to kind of have some fun, associate the color of a pixel with its location in the grid. And what's going on here is that the class is saying, hey, notebook, here's some HTML, display it. And conversely, we can tell the notebook, hey, take out whatever you're displaying here. So show something, take it out. If you put that together, you can actually do frame-by-frame animation with this, which is fun. So here's a little example of that. Right, so this is actually an HTML table that's being rendered, removed, and replaced. And so students can really get creative with this, which I think is fun. In boot camps where I've used this, especially for students that kind of were ahead of the class, have just kind of taken this and run with it and haven't had to sit there bored. Another project that's kind of cool that I'm not part of is called IPython Nose, and this brings the Nose testing framework into the notebook, so you can write your test functions or test classes right here, and then have that automated test discovery and running, which is so nice about test frameworks. So if I load this, define a couple of test functions, and then call this little nose command, you can see that things didn't really go all that great. I've got to fix all of this now, right? So we're working towards a fully green bar, and we can look at the tracebacks for those failures and errors and see what happened. So you don't even have to leave the notebook to teach test-driven development now, which is very nice. So your students have been working all day, doing all kinds of fantastic stuff, making pretty pictures. At the end of the day, they can press a little save button here in the notebook, save all of their work, shut it down, reopen it later, and everything they did is just waiting there for them, in exactly this visual way. And the format of the notebook is simple text. It's a JSON file, so you can email it, check it into version control. It's become extremely common in Python to share demos this way, to make a notebook demonstrating something and email it to people, or even better, put it up on the web, like on GitHub, and tell people about it. And the IPython developers have made a really nice service called NBViewer that takes the data in a notebook on the web and renders it in a static view. And so this might look familiar. This is the URL, or the result of the URL I showed you at the beginning. It's my notebook. I put it in a gist on GitHub and pointed NBViewer at it, and now it's there for you to read. So this is a really nice way, right? If you want to share something, you don't even, the person on the other end doesn't even have to have the notebook installed. They don't have to launch it. They can just take a look at it right in their browser. And you'll notice that there's a lot more text in here than in the one I've been showing you. It's because I made this to be kind of a standalone thing that people can look at without me talking at them. And there's even links in here. And this is all written in Markdown. You can put in Markdown cells in the notebook to do really rich text displays. You can put LaTeX in that Markdown to render mathematics. And so your code doesn't have to be alone. It can be accompanied by really rich descriptions, links off to other things, equations, which is really handy. So it's not all sunshine and lollipops with the notebook. There are a couple of things you have to kind of be aware of before you start working with it. One is the installation. You have to install IPython itself, and then to get the notebook working, there are a couple of extra things: Tornado, Jinja2, and PyZMQ. Experienced developers will have no problem with this. These are not, as these things go, difficult libraries to install. But installing anything can be tough on novices. So there are a couple of ways to deal with that. One is if your students are working on a server where you have control, you can just take care of this. They can connect to that server. You can start a notebook server there, and they can all get instances of notebooks on that server. For my software carpentry boot camps, I recommend all-in-one installers like the nthought Python distribution or Anaconda CE that come with the notebook and all of its dependencies already installed. And as a last resort, I have a Linux virtual machine that runs on VirtualBox that people can use if just nothing works. Another drawback to the notebook is that the Python debugger doesn't work because of some technical limitations of the technology driving the notebook. And I know they're working on this, so there will be a day when I will take this out of this talk. But right now, anything that uses like the raw input function won't work in the notebook. And that includes the debugger. So, which is a downside, because usually you want to teach debugging. There are a couple of ways around that. One is to, well, actually there's one really good way around that, and that is to connect a different type of IPython session to the same kernel that this is talking to and run the debugger from there. So when you start up the notebook, it will actually print a little message that says, if you would like to connect another interface to this same process, do this. And so you can connect the terminal Python or the Qt console to the same kernel and invoke the debugger there. Another tricky spot is that the state of the notebook does not necessarily reflect the state of the kernel, the Python kernel behind it. For example, I can rearrange all of these cells after I've executed them, right? And that obviously doesn't change the order in which I executed them. You'll notice these little numbers that show up here. These actually reflect the order in which things were executed. And I can even delete cells out of the notebook after I execute them, but that doesn't delete variables or functions defined within those cells. If I define a little thing there and then I just delete that, I still have access to that variable. And I don't actually have kind of a magic bullet for this. It's something you kind of just have to make students aware of and get them used to. But if students kind of do get into kind of a hopeless situation, it is possible to just restart the Python process and rerun everything you have in the notebook, which can sometimes kind of help you get back into a sensible environment if you've done something really crazy. So, but despite those things, I still think the advantages of the notebook are terrific. It's just a really nice environment. It simplifies things for students so they can just focus on learning Python, on learning computational thinking, and on practicing Python. And as a bonus, they won't stop using the notebook when they leave the classroom. Professional developers from all backgrounds use and love the notebook for most of the same reasons I've been telling you about right now. The help features, the quick iteration on changes, the multi-line editing, all of that stuff has made it a really popular tool, and especially the sharing too and NB Viewer have been fantastic. So not only is it a great environment for learning, it's an environment they will keep using for as long as they're programming in Python. So that is all I've got so far. I think I have quite a bit of time for questions or further demos. Again, here's the URL where you can see the rendered notebook. And you can tweet at me at Jiffy Club, my email, my blog at penandpants.com. And the IPython developers are here. Actually, several of them are right here in the room. But they have a booth over in the expo hall too, so you can go and visit and ask them questions too for the rest of today. Well, up until 5 o'clock, I think, anyway. So again, thank you very, very much for coming. It's been a pleasure.
So I'm sort of two questions. Is there a way to post directly to just.github.com from within the IPython notebook?
I know that Min has put together an extension that will do that. It's something you have to, right now at least, it's something you have to add manually to the notebook, but it's just like a magic, you know how I did %nose? There's like a %gist magic that Min put together that will just throw it up on a gist.
And then the other question I have is, when I'm teaching programming, I find that basically there's the actual programming part, this is a for loop, this is a if statement, and that takes longer than half a day or 2 days to teach. And then there's the stuff that's beyond that is much harder, where you can sort of show people that have the basics and they pick it up. Oh yeah, I can see why I would use functions at this point, for example. And I'm sort of curious if you have any comments on the trade-offs with Ipython blocks for things like that. It seems most useful right now for the for loop and if statement side of things, but I'm sort of curious how far you've taken it.
The time issue is definitely a big one, especially in software carpentry. As Titus well knows, we have a day to kind of get people into this. And I have thought about with Ipython blocks ways to kind of extend that, though the time required to get that in has actually made it difficult for me to actually try it out. But you saw, for example, that animation I did. I actually, for my boot camps, have all of that saved out as text files. So after students have written a function for reading text files, for reading in those text files, we can actually practice reading in a whole series of text files, putting that in a loop, and then putting in another loop to actually show, to actually render that animation from all of those grids that they read out of the files, which I hope kind of motivates the reason for writing functions is that code reuse and stuff. But definitely we could use more people looking at this and developing curriculum, and I hope you guys take advantage of my contact info here to send me questions and ideas.
So thank you very much for your talk. Also, thank you for everybody who's worked to develop Ipython and the Ipython Notebook. I mean, I think changed the game, and it's really cool. You've demonstrated things like tab completion and the help and stuff, and those are extremely common. What are some of your favorite, like cool but more obscure, less used features?
That is an interesting question. One thing that I actually took advantage of here in this presentation was that to get the font size a little bigger for you guys, I didn't use like the command plus thing like the enlarge, because that messes with the images I was putting in too. If I go up to the top here, I actually have a little hidden markdown cell here where I wrote in some CSS. So you can actually, and you never saw that, but so I can insert my own styling on a per notebook basis here, and you can actually, Ipython has this concept of profiles, and there's kind of, they have a location, they live in your home directory, and you can go in there and put in your own custom CSS and override styling in the notebook, and I've seen this used to very neat effect to change the typography to make it more appropriate for online blogging, things like.
If you open the gallery, on the gallery you have a couple of links to highly styled ones that are basically
okay. I actually turned off my internet connection so I wouldn't get bothered, but yeah, if you go to ipython.org/notebook.html, they have links to, they have like a video introduction, and then they've put together a really nice page of interesting or unique notebooks there that demo all kinds of things. And if you're interested more in Ipython blocks, if you just Google that and find it on my GitHub account, jiffyclub/Ipython blocks, I have a few examples, the same examples that I showed you up there. But people are going all over the place with this and getting very creative.
Yeah, I wanted to ask, is there an ability to edit particular blocks or turn the ability to edit blocks on or off? Like when teaching, if you had formulas, say in Markdown or LaTeX, and you wanted them to be able to play around with the Python, but not necessarily the formulas or instructions.
I'm sure that's possible. I have asked the developers before for the ability to add like hidden sections to the notebook where you could actually make a little button or a little link that says hint, for example, for putting in hints like they're hidden. And I asked the developers like, hey, would this be possible? And about 5 minutes later, they had posted an example of how to do that on GitHub. So the answer, you might have to hack a little bit, but definitely.
My question is, what happens if someone puts a while true in there?
Let's do it. So there's that automatic indentation, very nice. All right, so, right, it just sits there, but I can interrupt this. If you go up here to kernel, there's a little interrupt thing, and it's just like sending the keyboard interrupt to it.
Thanks.
I love that the console version of IPython is self-documenting, you know, hit question mark or quick ref. Is there an equivalent for the HTML notebook, some of the features that are specific to the HTML interface?
Well, first of all, the same things all work here.
Right.
He's talking about this quick ref. So again, that pops up down here. And this is actually meta documentation. It's actually documentation about IPython itself. I'm not sure, actually it is a little bit notebook specific, is it? Yeah, is it notebook specific or is it just the one? Okay, so it's not, this is,
Quick ref comes straight from the kernel.
right, so this isn't notebook specific. I'm not sure there is a place besides the online docs to get.
The help has keyboard shortcuts.
Oh, that's right, yeah. So there are keyboard, very Emacs-ish keyboard shortcuts for all of this that look kind of funny because of the things I did to the font size, but this doesn't really come up with teaching because students, I don't have students worry too much about this, but very quick workflows in there.
Hey, is there any kind of sandboxing or limitations to what people can do if you open up a port or have a server, or do you have to kind of trust whoever is on there?
Yes, you do. It's just a Python session, as if you had opened up IPython from a terminal. So you basically have to treat it as full access to the computer that it's running on.
So thank you, Davis, for a wonderful presentation.